Okay, I want to take a look at a problem that's in the homework, and it's on using the chi-square test of independence. So it says workers and senior level bosses were asked if it was seriously unethical to monitor employee emails. So what we want to see here is the responses from the workers and the bosses about monitoring employee email. So we have the workers' responses here, how many yeses there were by workers and how many no's there were by workers. And then the bosses also, 37 said yes and then 81 said no. So we want to see, is the response independent of the type of job that the person has there, whether they're a worker or a boss. So we're going to use Statdisk. And we have to type those numbers in the table. So we're just going to put them the way they are, 195 and 37, 249 and 81. So we type them in just the way they appear in the table and then go to analysis. We're going to go to a contingency table. Select the columns to include. We have stuff in columns 1 and columns 2. So we see our columns right here, 1 and 2. And then we're going to click on evaluate. Now they wanted us to use a significance level of 5%. So that's our allowable risk, or what we refer to as a predetermined probability of a type 1 error. So we're willing to take at most a 5% chance of wrongfully rejecting the null hypothesis. And then we look at the numbers here. And our chi-square test statistic is, this is chi-square, 6.07. And we have our critical value, 3.84146. So our test statistic is beyond the critical value. That's one way to look at whether we're going to reject or accept the null hypothesis, that they are independent of each other. So that we're saying that it doesn't matter what type of worker you are, that's our null hypothesis. And then we're going to maybe try to show that there actually is some dependence there. Now our p-value, which is the probability of a type 1 error, or the probability of wrongfully rejecting the null hypothesis. So our p-value is 0.0138. Our p-value is less than the significance level, which means we will reject the null hypothesis. So we see here, reject the null hypothesis. Data provides evidence that the row and column variables are dependent. Okay, so if we plotted that, we would see our skewed distribution. Chi-square is positively skewed. Here is our critical value, and then our test statistic is way out here beyond that. It's in our critical region. Okay. So if we go back to the problem, they say find the chi-square test statistic. And we had 6.07, 6.07, round to the nearest thousands. So we're going to have to throw another 0 in there. And then we're going to have to check the answer. Okay, so we got a well done on that. Now if you are interested in the expected frequencies, there's a separate video on how to compute the expected frequencies. Now it says use the given significance level to find the critical value. The critical value is, and what did we say the critical value was? 3.841. So 3.841. And we get a good job on that also. And it says, using the significance level, complete the test to claim that the two variables independent. State the conclusion. So we have a couple choices, and we would click